We're looking at organic reactions and reaction mechanisms. This is a topic under organic pharmaceutical chemistry or anyone that is offering chemistry. Organic reactions and reaction mechanism. Now, we're going to go straight to the point. If you're joining us for the first time, this is Exclusive Tutorials and I'm Dr. Best. Now, let's proceed. Now, what are organic reactions? Organic reactions are chemical reactions that involve organic compounds. It's as simple as that. Now, let's look at something very important, reaction mechanism. Let's use ROM for reaction mechanism. Now, what we'll consider as a reaction mechanism. Now, reaction mechanisms are the step-by-step processes that is involved in the transfer of bond from one atom to another, leading to the formation of a product. Now, let's say we have a reaction A plus B to give us C, right? Now, the processes that are involved that makes bonds to come together, reactions or compounds or molecules are joined together by bonds, right? This is a bond. Now, the processes whereby bonds leave from one atom to another to give you the product is what we consider the reaction mechanism of that reaction. Now, in this particular course, when you are taking an exam of this particular course, you will be required to write a lot of reaction mechanisms of many reactions to actually say if you understand what happens. Now, the reason why you need to understand a reaction mechanism is so that you can know what happens in this. And also, you can actually, as a pharmacist that you are, alter a reaction, make reaction happen faster if you understand what happened in the reaction. You can change the course of the reaction, the rate of the reaction, the product you should expect if you understand the reaction mechanism. So, reaction mechanism is important for pharmacists or chemists to be able to determine or control the rate of a reaction. Now, let's say, for example, I have a compound like this. Reaction between an alkyl halide and an alcohol. Now, this is going to be the product of this reaction. Reduce your voice. Now, this is going to be the product of this reaction. This is a substitution reaction where this OH from this compound is going to substitute this chlorine to give us this. But as a chemist that you are, you should understand what happened in case you want to increase the rate of the reaction or anything. So those processes that happened that left the movement of bond within this two reactant to give you this product is what we call the reaction mechanism. Now we are going to look at the reaction mechanism of this particular reaction. Okay, now this is what happened in that reaction. Now this is what happened in that reaction. Now, you know that compounds are joined together by bonds, right? These are bonds. These things you are seeing are bonds, right? Compounds are joined together by bonds. So there's a bond here, there's a bond here, there's a bond here, there's a bond here. Now, in reaction mechanisms, you use arrowhead. You use an arrow, right, to indicate what happened. Now, the arrowhead indicates the direction of the electron, which means where the electron is going to. While the arrow tail is the initial position of electrons, where the electrons were before now. Now, let's proceed. Now, in this reaction, this is what happened. Electron is going to leave. The electrons that form this bond between chlorine and carbon are going to leave to give you something like this. We are already on the reaction mechanism. Follow up to give you something like this. Something like this. Now, this is a carbocation. This is an electron deficient center. Because electron has left here. The electron here that formed this bond has left. So now, this carbon is short of electrons. Remember, carbon forms 4 bonds. There's a video I made on complete organic chemistry. If you don't understand the basics of organic chemistry, go back, watch that video. You're going to understand what I mean here. Carbon forms 4 bonds. Now here you are having 3 bonds. It has 8 electrons that forms 4 bonds. Now, each bond like this comprises of 2 electrons, right? So, since a bond is not here, it means carbon has lost an electron, right? Now, you're having arrow. Remember, OH is a positive, is negative, right? Since here is giving you, forget this. This is a positive charge that makes you that this carbon here is positively charged, right? Now, since you are having a carbocation which is positively charged, and you're having a molecule here which is negatively charged, now electrons will leave here. At this point, this is unstable. At this point, this is unstable. The electrons here forming this bond will leave here to come to this place. So first, there's a movement of electrons from here leaving this place to break this bond here. There's a movement of electrons from here to come to this place and give you this. OH plus RCl. This Cl here will come to this place and bond with this. So these processes that you are seeing that happened here is regarded as the electron mechanism of this reaction. So if you are asked to write the electron mechanism of a reaction, you should know it's just you explaining what happened in the reactions where electrons leave, breaking a bond, electrons come in to form a bond. So what you use is arrows to indicate the movement of electrons, and if you can indicate it, it means you have been able to show us the reaction mechanism of that particular reaction. Now we are talking about organic reactions, right? We have types of organic reaction: addition reaction, substitution reaction, elimination reaction, redox reaction, rearrangement reaction, pericyclic reaction, and free radical reaction. Now before we talk about all these types of reactions, right, I want to explain some things for us. Now we'll just explain the reaction mechanism. Now let's explain some terms that you are going to be coming across when talking about reactions, when talking about organic reaction. First thing is a carbocation. Now what is a carbocation? A carbocation is a molecule that has a carbon center that is positively charged. Now let's say, for example, we have this. This is a carbocation. Now, carbocation are regarded to be electrophiles. Now, what is an electrophile? Electrophile is a molecule which is electron deficient, which is deficient of electron, or a molecule that is positively charged. So they lack electron. Now, this positive charge is to let you know that this molecule, or this compound, or this center here, this carbon center here, lacks electron, right? Electron is missing here, so it is an electrophile. It lacks an electron. So in chemical reactions, a carbocation or an electrophile is going to bond to a nucleophile, to form a new product. Now what you are seeing here is that this center is highly reactive because it is not stable. Now it needs another unstable element, definitely a nucleophile, which has electron to bind to it to form a stable compound. So all carbocations are unstable. Now let's look at the next thing, carboanion. Now we just looked at carbocation as a positive center, or a molecule that has a carbon that is positively charged. Now carboanion is the opposite. It's just the direct opposite of a carbocation. This is a carboanion. Now let me show you the difference. Remember I told you that carbon is supposed to form 4 bonds, right? And we made it to understand that each bond represents 2 electrons. Now you're having 2 electrons, 2 electrons, 2 electrons. This is a lone pair, right? This lone pair means that carbon has excess electron. So this center will be negatively charged and is regarded as a carboanion. Now also, just like carbocation, this center makes this whole compound unstable, and it's going to need an electrophile in a reaction. Now, all carboanions are considered as nucleophile. Now, what is a nucleophile? A nucleophile is a molecule which has sufficient electrons, or a molecule which is rich in electrons. Now, remember I told you electrons are left here, right? This makes the center rich in electrons. It is called a nucleophile. So, in a chemical reaction, this center will look for an electrophile. Remember, nucleophile is electron rich. It will look for a center which is electron deficient to form a compound. So, carboanions are nucleophiles, carbocations are electrophiles. Now, the reason why we are looking at these terms are these are the terms you are going to come across when talking about reactions in organic chemistry. Now, let's talk about reaction intermediates. Now, reaction intermediates are highly reactive species that is formed between the reactant and the product. Now, let's say we have A plus B to give us C. Remember when we are talking about reaction mechanisms, there are intermediates there that are formed before the product is formed. But when you are writing a chemical reaction, you do not indicate this intermediate because these intermediates are highly reactive. They don't stand, they are not stable. So immediately they are formed, they transfer into the product. So, but just know that when you come across a word reaction intermediate, they are highly reactive species that are formed between a reactant and a product. Now, one more thing is activation complex. Activation complex. You are going to come across most of these words during reactions. Now, activation complex are the sum of all possible intermediates involved in a chemical reaction. Now, let's say, for example, we are having A plus B is equals to C. Now, all the intermediates that are going to form before the product is formed, they are together regarded as the activation complex of that particular reaction. In organic chemistry, we'll be hearing this very common almost every day. Lone pairs. I talked about it just now. Lone pairs are pairs of non-bonding electrons involved that are present in a compound. Now, let's just like I told you. Now, there's a bond here, bond here, bond here. This is regarded as a lone pair. There are electrons that are not involved in bond. Remember, each bond comprises of 2 electrons. So, these are not involved in bonding. There are no bonding electrons present in a compound. So, they are regarded as lone pairs. Now, the last thing we'll look at is heteroatoms. Heteroatoms. What are heteroatoms? Heteroatoms are non-carbon, non-hydrogen. They are non-carbon, non-hydrogen atoms that are present in organic compound. Non-carbon, non-hydrogen carbon. So any other atoms that is not carbon, that is not hydrogen, in an organic compound are regarded as heteroatoms. E.g., your halogens, chlorine, they are all regarded as heteroatoms. Now, done with this, let's come back to types of organic reactions. Numerous types of organic reactions, but we're going to just look at them and make them so simple. First of all, we have addition reaction. Normal mathematics, right? Now, if this is addition reaction, if I have this blue marker and I have this black marker, now I bring them together to give me blue and black marker. Is an addition reaction. It's as simple as it is. A plus B. Addition reaction is simply A plus B is equals to C. Simple. Now let me give you. Addition reactions are mostly formed between unsaturated organic compounds. Let's say, for example, we have something like this. CH3, C, you have H here, H2 plus Br. This is an addition reaction. Now, you are having an unsaturated organic compound, right? addition reaction, the presence of this double bond gives room for you to bring in another atom to make this saturated. So addition reaction is only possible where there is either a double or a triple bond, because this gives, if this bond is broken, right? Remember, each bond is equals to 1 electron. If this bond is broken, you can bring in atoms to fill in this. So you're going to bring in atoms that will break this bond and form another compound. So this is an addition reaction. So by the time we react this, we're going to have CH3, CC. This double bond is broken already. So you're going to have this. You're going to have H here. You're going to have 1Br here. You're going to have H here. You're going to have 1Br here, and you are going to have H here. So this is an addition reaction. You are breaking this bond to introduce bromine atoms to form this. So this is just an addition reaction, bringing in an atom into an existing organic compound. Remember, everything we are talking about is an organic compound, right? Organic reactions. So this is an organic compound. I'm introducing a bromine atom into an existing organic compound without removing anything or anything in the reaction, or without substituting anything. It is considered an addition reaction. Now the next one is substitution reaction. Now this is a substitution reaction. Just like you watch football, for those of us that are football fans, if you're having your club, I'm a Man United fan, if you're having Man United play match and you happen to have Rashford on the field of play, 11 players are playing. Now, when you are introducing Garnacho from the bench and you are removing Rashford, it is called a substitution. You are removing one player from all the players and bringing in a new player. So that is substitution. So which means that a substitution reaction in organic chemistry involves you removing an atom in an existing organic compound and replacing it with another atom in the same organic compound. It's as simple as that. Substitution reaction. Now let's take, for example, ROC HCl plus ROH. Just like the example we used before, right? This is an alkyl halide and alcohol. Now, in a substitution reaction, this we call this a leaving group, right? Now, once this group leaves, it's going to create, just like I told you, a very reactive center here. Once this group leaves, this bond here will be broken, making here positively charged, a carbocation. Now, remember OH is negative, right? So this OH will come and substitute this chlorine here to give us this. OH plus RCl. So what I did is that I substituted chlorine with a hydrogen. It's as simple as that. So we'll call it a substitution reaction. Remember, here chlorine was here. So I'm bringing in an atom to come and substitute an existing atom in an already existing organic compound. We'll call it a substitution reaction. I'm done with substitution. Now the next thing is elimination reaction. Elimination, just like the word implies, I am removing something from an existing organic compound without replacing it. So it means I have eliminated an atom. I'm removing an atom from an existing organic compound. It is simply called elimination reaction. Now, elimination reaction mostly happens in saturated organic compounds. So by the time I carry out an elimination reaction, it's going to create a double bond to balance up the compound. So the compound is going to turn from a saturated organic compound to unsaturated organic. Let's take this as example. I have OH here, and I'm eliminating some atoms from this compound to give me another compound entirely. This is a saturated compound, right? I want to remove water from this compound. I don't need water in this compound. So I'm going to remove this and this. I'm going to eliminate hydrogen and hydrogen group, which is together water, to give me another compound entirely. That is elimination reaction. I did not substitute, I did not add, I only remove. So this will give me this. Remember, immediately I substitute this, a double bond will form, which will change the compound from a saturated compound to an unsaturated compound to give me this. So I'm going to have this at the end. So this is an elimination reaction. We are done with elimination reaction. Now let's take redox reaction. Now, redox reaction is a reaction between organic compounds that involves reduction and oxidation at the same point simultaneously, where oxidation and reduction happens simultaneously. Now, what is oxidation reaction? In the simple terms that we have, oxidation reaction is addition of oxygen or removal of hydrogen, while reduction reaction is removal of oxygen or addition of hydrogen. Now, let's say, for example, what happened in this reaction that gives us to glucose, 6CO2 plus 6H2O, carbon dioxide and water, to give us glucose and oxygen, right? Now, in this reaction, this is CO2, right? Having 12 atoms of oxygen, and this is water having 12 atoms of hydrogen. Now, we are going to reduce this compound and oxidize this compound at the same time, simultaneously. So this will give us 6H12O6 plus 6O2, right? Plus 6O2, right? Now, this compound before, this carbon compound, right? This is actually the organic compound that contains carbon, right? This compound is reduced because here it was having 12 oxygen. Now it has reduced to 6 oxygen. This compound is water. It was having 12 hydrogen. Now it has just oxygen. So the hydrogen here has been removed and oxygen has been removed from here at the same time. So simultaneously removing an addition of reduction and oxidation in a reaction involving an organic compound, it's a redox reaction that is carried out by organic compound. Now, rearrangement reaction. Rearrangement reaction, which is number 1, 2, 3, 4, 5. Rearrangement reaction number 5, it just involves the rearrangement of rearrangement of an atom from one center to another in the same molecule. Nothing is changing. The same molecule, you are just rearranging a particular atom from one center to another in the same molecule. Now let's look at this. 3CH3. You're going to have H here, H here, H here, H here. Now, by the time I rearrange this compound, right, I'm going to move some atom from a particular center to another. So I'm going to have something like this: CH3, C, CH3, CH3, H. The same molecule, the same compound. I just rearranged. I just took away this this atom here and brought it here, right? Then I brought this one here. So I just rearranged it to give me this. The same compound, nothing changed. I just changed some atom from a particular center to another. So I moved this atom from this center, brought it to this center. Or we can use another example. We can use this. Let's use this. Right. So here, let's have OH group here and have arrow here. Now, if I choose to rearrange this, I will move this arrow from this center to, let's say, this center here. So our OH will still be there, our arrow will now come here. This is just an example of a rearrangement reaction. I just move an atom from one center to another. I did not alter anything. I did not change the molecule. The same molecule, but I just moved an atom. Okay, we are done with rearrangement. Now let's look at pericyclic reaction. Now, pericyclic reaction is a type of rearrangement reaction that gives birth to a cyclic product. Now let's say, for example, we'll have this, right? And we'll have this, this, this. This plus this. These are two existing compounds, right? We are going to rearrange them to get a cyclic product. That's all. Now here, this is what happened. This comes down. I take this one up and I bring this one here. This is going to give me a cyclic product. Just watch. Now, this is what I have here, right? This one came down, so I'm going to have this. This one, remember I have something here already. I have something here. I have something here already, right? This one moved here, right? And this one that is here, I bring it up, rearrangement. And this one that is here, I brought it here to give me this. So the product I'm going to have is a cyclic product, right? It's a cyclic product. Now, this is my product here. I just rearranged this to give me a cyclic product. This pericyclic reaction is a rearrangement reaction that will give you a cyclic product at the end of the day. Now, the last one, which we are looking into, it's a free radical reaction. What is a free radical reaction? A free radical reaction is any reaction that involves a free radical. Now, what is a free radical? A free radical is an atom or group of atoms that comprises of a single unpaired electron. Remember we said a lone pair is two unpaired electrons. A free radical is one single unpaired electron. One dot is a free radical. Now let's look at this reaction between methane CH4 and Cl, right? To give you this HCl plus CH3. There is a free radical here. So the presence of this free radical makes this a free radical reaction, right? Remember, this is supposed to be completely bond. So one hydrogen leaving to bond with HCl means this compound is short of one hydrogen, which is one electron. So since this compound has one unpaired electron, it is considered a free radical. So we have looked at the major reactions. Here we have looked at organic reactions as a concept, looked at reaction mechanism, looked at a lot of things. We have looked at what we call carbocation, carboanion, nucleophile, electrophile, transition, reaction intermediate. We have looked at activation complex. We have looked at a lone pair. We have looked at heteroatoms. Now we have looked at all the types of reactions: addition, substitution, elimination, redox reactions, rearrangement reaction, pericyclic reaction, and free radical reaction. We have come to the end of this class, organic reaction and reaction mechanisms. On the next video, I'm going to be doing more on SN1 and SN2 reaction, and also E1 and E2 reaction. SN1 means substitution nucleophilic 1, SN2 substitution nucleophilic 2, E1 elimination 1, and elimination 2. These are types of substitution nucleophilic reactions and elimination reactions in organic reactions that you need to know. Now, to make sure that you understood everything that was discussed here, the following are questions on this video, organic reaction and reaction mechanisms. I want you to tell me the right reactions in the following organic reactions here, and the first person to get the 5 questions correctly wins a 1K cash from me. Drop your comments on the YouTube comment section, and get ready to win a 1K prize. Don't forget, it's Dr. Best and his exclusive tutorials. Feel free to make sure you subscribe to this YouTube channel, and whenever you want any video for us to make for you on chemistry, biology, mathematics, pharmaceutical chemistry, and pharmacology, just drop the topic on this comment section and we are going to do it. And if you have any question regarding this particular topic or video, post it on the comment section and I will attend to it, or you can send them to exclusivtutorials01@gmail.com or any of the numbers on your screen. Don't forget, I love you and I bless. God bless you. Now, before I leave, I will leave you with this quote of mine: in everything you do in life, give your best to it, for only then will you be happy with yourself. I'm Dr. Best and I'm the happiest man alive. Bye.